Thank you for joining us here with Clemens Dimpers, calling us all the way from Finland today, although he's got a long background in South Africa. So Clemens joined us last year, likewise, just at the end of the year, with an overview of AnyLogic. And today is meant as not a duplicate, it is meant as a continuation, perhaps, of what we covered last year. We've got a great audience representing a number of different industries and sectors, so excited to have Clemens share various insight from his standpoint. So Clemens has a long background working with AnyLogic. He's the CEO of Polar Analytics. They specialize in green sustainable solutions to industry and specialized technical and business software products and consulting services. And then likewise with South Africa, he's the director of Blue Stallion Technologies, which distributes scientific and academic software across Africa, including Wolfram, Mathematica, AnyLogic, and Origin. He has 20 years of experience with these products, including a wide range of consulting projects and training courses around the world. So Clemens, thank you very much for joining us. I'll go ahead and hand it over to you, and then we'll jump back on at the end for question and answer. But take it away.
Good. Thank you very much, and thank you very much, everyone, for joining us. Can I suggest that when you have a question, maybe just interrupt, because sometimes if we leave the questions for the end, we run out of time. And secondly, sometimes if you have a particular interest or question, then I might maybe focus more on that aspect instead of telling you things that you might not be all that interested in. So just do that, and please just maybe Ben, if you see someone raise their hand politely, just mention it to me, because if I'm between different screens, I can't see whether someone has done that. I prefer that someone maybe sometimes just interrupt me. Good. So let's start off by sharing my screen. Hopefully you can see this.
We see the presentation, yes.
Good. Okay, so we're off to a good start. Okay, so what I want to do is to talk about simulation modeling and give you some ideas of how it can be applied practically in quite a few different fields. So once again, if I don't know how many of you've attended last year, but let me bore you again, because this is always a good place to start, and that is to define and to explain exactly what we mean by modeling. So why do we do modeling? Well, because we have problems in the real world that we don't know exactly how to solve. That means we cannot just try different options. It takes too long, or it costs too much money just to try things out. So therefore, what we do is we build a model. And it's important to understand that the model is just an approximation of reality. It's just the abstraction of reality. We cannot possibly model everything exactly as it happens in real life. So in a way, modeling is a bit of an art as well as a science. An art because you have to decide which aspects you will be modeling. And then once we have this model, we can then solve it at the level of the model. And then if that was a good model, we would then have a solution of what we should do in real life. And I should also mention that mostly this is not just a single process. Quite often there are multiple iterations. It's better to build a very simple model first to give you quick answers, and then afterwards to maybe refine it because you realize it doesn't quite corresponds to what is happening in real life, and then you refine it from there. But this world of models is a risk-free space, so you can run a whole number of scenarios. And I have a small model a little bit later that I'll actually show that I think explains that quite nicely. Okay, now the kind of model that we have, and this is not just true for simulation modeling, but for all kinds of things. We have mental models of how the world works. We can build physical models. There can be analytical models. But what we're talking about today specifically is dynamic simulation models. And then let me also just clarify a few things, because people very often talk about animation, emulation, and simulation. So what are the differences? So when we look at animation, it is just really maybe quite accurate movie of how something works, maybe to visualize warehouse operations or rail operations. So it's only visual. It doesn't actually calculate or do anything. It just represents how things look. Then what emulation is used very often to test software and hardware before you really implement it. So without the systems having been installed in your manufacturing facility, you would run these to see whether they would behave as expected. So it's functionally accurate, and it's typically being used for automation or integration, and so on. And then simulation, in a way, includes the functionality of animation and emulation, because it is behaviorally accurate. You can do all kinds of calculations and come to all kinds of insights by looking at the output. Throughput analysis, bottlenecks, and so on. So an example of that is simulated forklift traffic during peak hours. And once again, we'll look at something like that. So that is what simulation is, and that is what we'll be focusing on today. Now, since quite a few of the attendees today are from a background of logistics, I thought what we'll do is to just look at that and maybe suggest why simulation might be a good tool for that. So the simplest way, or the highest abstraction level really, for logistics is to move things, or to move from point A to point B. Now, that really means, and that's what we really do when we transport things, we move between two physical places which are a certain distance apart. And therefore, it takes us a certain time to do that delivery or that particular travel that route. But as we all know with traffic, there's always uncertainty with breakdowns, traffic volumes, and so on. So we never quite know exactly when we'll arrive at B. It depends whether there was an accident or something else happening. And then once we are at B, it might trigger another event, and maybe things are then shipped from C to D. And that is very simplistic. In real life, there's actually very many of these objects and parameters. You know, where is it? When does it ship? How does it ship? And that shipping fleet, is that actually something that we own or that other people own, we rent, so on. So it's much more complicated than that. And then a layer above that is not just the physical shipping and moving of goods, it's also the interaction with other processes, our ERP system, our sales, our forecasting, our manufacturing. All of this need to fit in within this supply chain environment. So all of these variability and details can be very nicely fitted or seen to by dynamic simulation modeling, because it shows how your system moves through time. Now, if any of you have used some optimization tools, maybe linear programming before, you would give it a certain set of inputs and say, well, this is it. Find me the optimum solution. And it would pop up with the answer and say, the setting should be this, or, you'll have so many forklifts, so many trucks, and whatever it is. It would just give you an answer. And that is indeed very valuable. But what dynamic simulation modeling adds to that is it adds insight to that, because you can see how that process changed. Because maybe to do this linear programming model, you would say, well, over a year, this is my typical production rate, or I have these trucks at this position, these forklifts, the stock there, and I need to have these constraints. How would I get to that? How would I be able to deliver that? So that sort of isn't very accurate, because as we all know, hour by hour or day by day, things change. And on the average in a year, okay, we can supply that, but it doesn't really then show us just before Christmas, there was a particular rush, or there was a big general strike in the middle of the year, and that then affected things. So we want to be able to see how our system reacts to those shocks. And that is why dynamic simulation modeling comes in, because here we have a certain number of inputs into our simulation model, and then we see how it change in time, and then give us a certain output. But the output isn't just a once-off output. Because the model is stochastic, if something else happens, you might get another output, and you might get another value in the end. And that is exactly what you want to see. You want to sort of see these risk events, these uncertainty, and how that would play out. So everything is visible, accessible, and measurable during this simulation run. And you know why things happen. And for me, that is quite a important difference. Now, what I'll be doing is I'll show some practical examples. And in fact, I'll even give all of you the opportunity to play a live online game, and we can see who makes the most virtual money. But we'll get to that soon. Let me perhaps just introduce AnyLogic, the tool that we use, and specifically just to give you an overview of where the applications are. So first of all, let's start with what it does not do. It isn't a detailed engineering control system. So if you've used tools like MATLAB Simulink or Wolfram Mathematica or fluid flow analysis, it doesn't do that, but it does just about everything else. Or you can think of it, it does business applications. And there's a whole range, and I'll show you live examples of this a little bit later on. For instance, a warehouse, how the forklift moves, the actual movement of the forklift. So that is close to physical, how people might move, how cranes might operate, and so on. But then we can also look at smaller scale logistics, things like rail cars, rail yards, traffic, vessels being loaded. So these kinds of models can also be built with AnyLogic. And then we can look at larger scale models, maybe supply chains between different parts of the world, between different warehouses and facilities within a country. And then we can go to even a larger level, or a higher level than that, a strategic level, where we don't really look at sort of the physical things moving, but rather the general change in trends and how the one affects the other, and what the feedback loops might be for that. So AnyLogic has been around for a long time, and it has quite a sizable community as well as user base and market share across the world. And the users of AnyLogic are most of the larger companies worldwide. And in South Africa, we have a whole range of users too, including consulting companies, rail companies, and mining companies. Then the product is available across the world. They have an office in Europe and North America. The main office is in North America, and then they have different distributors in different areas of the world, and we down here. Okay, so now for something more or quite practical, I hope. So the most popular modeling tool all of you've used is Microsoft Excel. And it is a very powerful tool, and it's a very good tool for certain applications. How it works, not that I need to tell you, but you typically have an input where you type certain things in, import things, then you do different things with this tool and it gives you a certain output. The kind of things that you would do is there would be some analytical solutions, some macros or formulas that you apply, and it then gives you an output. And just because this tool is so widely used in business, very often it's also used maybe for things it shouldn't be used. And I want to give you one practical interactive example of that. So my simple example is the following. We look at a warehouse, a very simple setup where we have forklifts that gets orders, they pick the orders, and then the orders are dropped off and it would go back and pick another order. So our problem is this, or how you would typically maybe try to be tempted to do this in Excel is as follows, that you have some data that's given to you, and you have to decide, well, maybe I should just jump back. So the idea is you have to find out how many forklifts you should use in your warehouse and to give you a certain throughput. So that's really the goal of this sort of virtual exercise, right? So what one can do is you can say, well, because we know the average pallets per order and time to pick a pallet, we can calculate that a forklift has to have a certain pick rate, and we can see how many pallets a forklift can pick in an hour. So a pallet per hour by one forklift, typically, or 5.3 pallets can be picked. And then the total pick rate to be able to do all your pallets within a working day, which might have 2 shifts, means you have to have 96 pallets per hour that need to be picked. Now, let me jump to my tool, which is here. And let's start very simple. So let's see, I have one forklift, and then I start running the model. And maybe what I should do is just to make this a bit larger. I hope everyone can see. So what I have here, I have one forklift that's now going to start picking. And then I have these 5 here, and what they do, they're just replenishing the material in the shelves. And then in the shelves, we have 3 colors. The red is the items, the volume items. So an order would have a random number of items in it, SKUs in it. The red SKUs move the fastest, then we get the green SKUs, and then we get the orange SKUs. So currently, no pallets have been picked per hour, and are also looking at the distance that this picker is traveling, right? So now it's busy. There's a problem with some of these other guys around, but you'll see it picked this side, then it picked that side, then it picks this side. So the idea with the first scenario is the forklifts will sort of pick in this zigzag option. And now let's just speed up a bit. So now you can see we get to about 4 pallets per hour, 5 pallets per hour, 5.33 pallets per hour. So if I have one forklift, I get about 5.3, 5.2. So that looks good, right? So now to calculate how many forklifts I might need, where is my Excel? I get 5.3. So now I just say, well, my pick rate is this. One can pick at 5.3, so let me divide this by that, and I get about 18 forklifts. Right, so let me jump back to AnyLogic, which is hiding somewhere here. Actually, that one is hiding here. Okay, so now I can say, okay, that's fine. So now instead of 1, let me go to, let's make it 20, just to give me a few extra. So now I can run this, and immediately you see something happening. Did you see that whole big bunching that happened here? And it just carries on. And remember, we were supposed to get about 90, but here at the end, we get 64. And you can guess why. Because all the forklifts are now competing here for rack space to pick, and only a few of them can do that at any one time. And therefore, this is not the most accurate way of doing it, because just to jump back to this, because it's not linear. So our Excel, which used a formula of just the calculating the rate, said close to 100, because I just divided what one could do with the total amount. But if you actually run the experiment, you can see it sort of edges off here. So the more forklifts you get after a certain point doesn't mean that your picking rate increases, because these forklifts compete with one another for movement space. So for certain kind of problems, you have to be very careful if you use Excel. Specifically, this kind of problem that involves, or model that involves, spatial dynamics. And now how one can use this tool is indeed then how to explore this. Because we can say, okay, well, now if I have 20 forklifts, they can only get to about 64 pallets picked per hour. But is there something I can do? Well, one of the things I could perhaps do is to say, instead of picking crisscross across the aisle let me sort of snake up the one side, then turn around, come down the other side, and so on. Sort of a S kind of form. So I can do that, and I can rerun this example. So now they would go up the one side, come down the other side, and I would now run the second scenario using the same random events that happened previously as far as the orders that arrived. If I now stop this, I can see, well, that is actually slightly worse. Instead of 64, I now only have 58. But there's a third option that I thought about, and that is we keep the racks as they are, but how we place the SKUs on it, we change. So what we do now is, can you see all the red SKUs are closest to the front, and then we get the green ones, and then we get the orange ones. So that now allows the forklifts to get access to all those in front, which I do most frequently, and those further behind least frequently. And now we can see there's a big increase from this, which was 64, 58 to 83. So that is quite a big increase. And then secondly, here, I kept track of the distance that they traveled per hour. And the second scenario was actually more, and this one was slightly less than the initial one. So it's the best because they pick more per hour and they travel less per hour. And then there are all kinds of things that we can do. For instance, we can redesign the racks, maybe put them slightly further apart, see how many of these we would then need to be able to give us our 90, and so on. So this is a good example of simulation modeling and the kind of benefits that you can get with it. Any questions before I quickly move on? Okay, so let me jump back to presentation again. So what does AnyLogic do, and what makes it different from other simulation tools? I would say practically the range of applications that you can tackle with AnyLogic is what sets it apart from other tools. One can do, I don't know, drone delivery, rail yards, emergency evacuation of people, warehouses. Essentially, you think of it, and you can do that with AnyLogic. And the reason it's so flexible is it combines three different modeling paradigms. The one is system dynamics, the one is discrete event, which most people are familiar with, and then agent-based modeling. And then on top of this, it has certain libraries like a pedestrian library, a road library, a rail library, process modeling, fluid flow. Fluid flow is fluid, like in oil, water, hot chocolate. But it can also be mining ore, and then material handling. And how you would build an AnyLogic model is you as the user would sit in front of your computer screen and you would drag the different ways of doing it. And it's not one of these, it's typically a combination of them. So first of all, you can use a domain-specific library and just drag and drop certain elements onto your canvas and build a model. And then these would use these discrete event system dynamics or agent-based, or you can build directly in them. And then you can further extend it with Java code if you so want to, because AnyLogic is built on the very popular Java platform. And then on top of all of this, we can also perform experiments. like optimization, calibration, and so on. And I'll also show you an example of those too. Then AnyLogic has GIS maps integrated into it, so it is very efficient to build these kind of, and easy to build these GIS kind of maps. As far as agent-based modeling, agents support state charts, so we can do very detailed models, which are not possible with ordinary tools, analytical tools like linear optimization. And the other important thing that I already mentioned or hinted at is that our models, we don't have to decide whether the model is going to be discrete event, agent-based, or system dynamics. We can mix these up within one particular model. And a good example of that might be that we use some agent-based model, which shows us how AGVs move within a factory. And those AGVs might be electronic, so it might drain the battery, and the battery might be drained depending on the load, the temperature, and so on. And if we want to model that accurately, we can use system dynamics, which is the sort of continuous change of states to model the state of the battery. And we can also create digital twins, actually construct the model completely from a database. All of these options are possible. And yes, it links to a whole range of external tools, even to Python, to Excel, maybe for financial or other calculations. You can do all of that. Now, let me give you one example. Once again, supply chains, how all of this can be brought together. So maybe I have to build some model where I look at some maybe mining, some logistics, some business processes. So the type of model that I might build to describe these might be discrete event, because typically, there's some queuing, things are handed off, there's a certain flow of things within the warehouse or factory. But then we can also look at how these different facilities are connected to each other. Because it's not just important, how our factory produce. What is important is how our factory might get raw materials, and how those things that are produced in the factory would be moved away from there. So what we want to do is we want to bring in where the things come from and where it would go to, maybe our distribution centers. And what are these different routes? And then what kind of traffic would we use between these routes? So this whole supply chain can be very accurately or very nicely modeled with agent-based modeling. Because the truck can have certain decision processes built in that it would do this route. But if there's a breakdown or a problem with the rail, maybe some of the trucks can help out on that leg or fetch raw materials from somewhere. So these ways of moving things can have their own decision logic built into them. And then finally, this can be extended with system dynamics to the market, because it's not just important how all of this is delivered to the warehouses or distribution centers, but also how people behave. So maybe you want to build something that looks at the demand or the financial aspect or the marketing, and AnyLogic can also be used for that. Okay, so let's quickly look at an interactive game, and this is where you can all participate. So if you go to this URL, and the easiest is if I can just paste it here. So I'm pasting it into the window. At the bottom. So I don't know if you can see that. And then what I will do is I'll just use one of my browsers and then paste it in here. So I should now see what you see. And why I show you this is also another feature of AnyLogic. When you develop a model, as I've just shown you this sort of warehouse model, I can also export that model to the cloud. And once it's on the cloud and you give someone a URL to get there, they can actually run it. So this is not a movie, this is an actual model that runs in the cloud. And that is very powerful, especially if you develop some model which you want to distribute within your organization, or you want to send it to customers to understand, how your processes work. So now to run this model, I would click here and it will start. So let me perhaps just give you some kind of quick overview. And the background story is you are a manager of a beverage facility. Let me just stop it. And you have to try to make as much money during the run as possible. Note that you cannot spend more than 5 minutes real time because this is a free cloud version and it times out after that. So if you want to get more information, because this is just really to give you a taste, you can run this at home or at work later on. It has a detailed information that will tell you how it works. And we can also look at things in 3D instead of just 2D. Then what you can also do, you can zoom in and you can move around and you can do all of these things. And let me get running. So what happens is trucks arrive and then you would send some forklifts to unload those trucks. They would stage here and then other forklifts would move it from the staging area in front there where it would be staged, and then forklifts would load it into stock. Then when the order arrives, it would be moved to picking. You would do the picking and then it would be staged here and the order would go out. What you have at the bottom here is what your cash flow are. So you have so many credits available. And what you can do with that is you can buy a forklift. Now, look, if I buy a forklift, you can see that went down by 7,000. Now I have more forklifts. Or I can buy an AGV, which is actually faster and can carry more. So that is good. And now when I have an AGV, hopefully I would be able to operate faster and make more money. Or maybe I can buy a picker. And you see that is faster than before. And you would then typically run through this, which I'll do very quickly. And you would then see at the end of it how much money you've made. And maybe later on you can share and have a competition with one another to see who can make the most money in running it. So what you can also do, by the way, you can now start selling things. If you now sell a AGV, that would give you more money. You see your money jumped up. Maybe you decide to have an automated retrieval system. So now you no longer have to use forklifts to move it from here to outbound staging. That happens automatically. But now that is quite expensive. So your cash flow dropped. But maybe now you don't quite need as many forklifts as you did before. And then if you have even more money, you can now install an automated storage system. So now, as you see, things are loaded here much faster than previously. But each of these investments will cost you a certain amount of money. And then depending on when you did that, you will end up with a certain cash flow at the end. And the idea of the game is to time it such that you pick, buy, or sell the right equipment to give you the biggest amount of cash in the end. Right? And I leave it up to you to play with this and to see what the biggest amount is that you can come up with. But this is available to you afterwards too to play with. And maybe I should now just jump to the general AnyLogic models. You can go to cloud.anylogic.com to sort of view some of these. So some of these have been done by consultants. There's one, for instance, a container terminal. And once again, you can run these models, and this is not just a movie, it's the actual model. And it looks at the process of offloading containers from vessels. And these cloud models can also have your own data, which you can read from a database, or you can enter the data, as we've just done with the other model, by clicking on buttons or enter different values. So this is a very efficient way of distributing the model that you have already developed. And what is always quite impressive to me is to see the total number of models on here is 20,000. So that is some students, some consultants, some people who's interested in building these models who've uploaded it. AnyLogic also have some example models which they've uploaded here. But what you can see is they go a whole range of different models available in manufacturing, but also, for instance, in healthcare, a trauma center, for instance, how that can be modeled. Because maybe you have to decide on staffing, or you have to decide on equipment. So you can visualize the model, but then more importantly, you can also visualize the statistics. You know, it's open from what time to what time, and then how many doctors do you have? If you have 5 doctors, typically the utilization is quite low. Specialists have a larger utilization, you only have 2 of them, and so on. What is the length of stay in emergency? And so on. How many rooms do you need? So you can use these models to explore all of those. And then maybe let me quickly show one of our models that we have. That's not a real manufacturing model, but in a way it is, because how it works, and sort of a hidden feature, and I've hidden it there. So you have, and you can go to English, and it would automatically translate it. So you have harvester, which harvests some reed. And then that harvester typically moves to a barge, which is on a lake quite close to it. And when the barge is full, it will then move to the shore, and a loader would then pick up the material, sometimes crush it into smaller pieces, and then load a truck. So you can type in how big your field is. In this case, we have 1 harvester, 1 barge, 1 loader, 1 truck, and we can then run the model. And each of these bits of equipment must be rented, so there's a certain cost involved. And in the end, if you want to harvest this field, it will tell you this is a total cost, and this is the total time it took you. And you can also see how it was broken down, between harvester cost and barge cost, and then finally the truck cost. So what you can then do is to look at this and say, well, no, wait a second, I want, 2 harvesters and, I don't know, 2 trucks. I'm just making this up. And if I run this now, is it going to be cheaper? And you see, it is a little bit cheaper. Well, what if I now deliver directly to the shore with my harvesters so that I don't actually need any barges? So I can also do that. And now I see, well, that maybe wasn't such a great idea. And obviously, what would determine this is the distance that you have to travel from a particular place. So what one can do here is you can then also look at the sort of the total combined spending which you have, and which are the best one or the preferred one to go for. And then very briefly, the last thing I want to show using AnyLogic is how to use optimization, because your next question should be, actually, no. I just want to very, very quickly show a model which I downloaded from the internet. That is a manufacturing example model of furniture manufacturing. And I have to speed this up, where, and this is maybe too much, where equipment is now being moved through different stations. And I can, for instance, zoom into the cutting or the, I don't know, assembly part of this. And then I can also look at the data, because that is obviously the important things, because maybe I want to, look at certain KPIs, and all of these KPIs I can define according to how I want to look at them. And then what I do want to show you, the final thing we have time for, is activity-based costing analysis. And this is a very simple model that is quite tricky to solve manually. So I have products that arrived, then they queue, and I can change the rate at which they arrive. Then they seized by a resource, and currently there are 12 of these resources. Then they go into another queue and to resource B, and there are 15 of them, and then there's a certain machine there, then they wait, and then they release. And each one of these actions, we calculate how much it cost us. So in the end, to make the product might cost $117 US. And the cost structure is broken down like this. Most of it is with things just waiting idle. Some processing time and some conveying time. There's no waiting time. And I can then sort of start changing these randomly, or what I imagine it should be, and then see how the price change. And miraculously, right, no, now it starts going up. So the question is, you build a model like this for your manufacturing facility. How do you decide which optimum values you should have? And one of the ways is just to use AnyLogic's built-in experiments. On the right one, I did. So what I can do here is I can run this. I don't see the simulation moving. What AnyLogic is doing in the background is just to run it multiple times, and in this case, use some kind of algorithm to determine the optimal values. And it then says, well, the best value I can expect cost is $60 if I chose 4 of resource A, 5 of B, and this is the mean process delay, and that's a conveyor speed. And I can then paste this back into the original model and then get an answer for that, and then see, carry on with my development. So it's not just visualizing how your system works, it's also finding the optimum values according to your particular definition. Okay, how are we doing for time? There hasn't been any specific questions, so maybe I should give people opportunity to ask questions now.
Yes, thank you very much, Clemens. So let's hear from the audience. Any questions that we have? We've got about 8 minutes left until the top of the hour, so we welcome your input. There we go. We got a hand up from Chris. Chris, feel free to come off of mute, or you can type it out, whatever you prefer. Chris, I've just allowed your mic, so if you want to come off mute, go ahead.
Oh, thanks, Ben. I thought it was me getting stuck on this side. Clemens, I want to check for the simulation. If you run a scenario where on a weekday you run 3 shifts of 8 hours a day, Monday to Friday you run 3 shifts, 8 hours, and then weekends you run 2 shifts of 12 hours. Can that be built into the simulation?
Yes.
Okay. And then in terms of optimization, you specify maximize or minimize. So minimize cost or maximize throughput.
Yes, exactly. I didn't really show that in detail because there wasn't time. So you can either maximize, minimize. You can even do parameter variation or Monte Carlo, any of those.
Yes. All right.
Yeah. So you can do staffing, sort of staffing, equipment, I don't know, turnaround time, all of that. We've just actually completed a rail project in the last week that looked at the redesign of a certain facility and how many trains can be cleaned within the specified time or design parameters.
Thank you.
Good.
Thanks, Chris. Anybody else with a question?
It seems as if the whole of Transnet is here.
Yeah, I think Chris has done a great job of advertising internally, so glad to see everybody join us.
It's our lunchtime, Clemens.
There we go. We got one more hand up from Jayan. I'll go ahead and allow your mic if you'd like to come off of mute.
You're still muted.
Hi there.
Good.
I found the unmute button eventually. Yeah, so my question is, can you incorporate into this model for in terms of the different skill levels of the operators of these various types of equipment? Can you introduce that dynamic for different shifts and ask the model to see if they can optimize for redistribution of these skill levels to optimize the output, if you know what I'm saying?
Yes, I know, and that's a very good question, and I didn't mention that. We actually recently did that for a warehouse where the question was that the operators there pick up skills the longer they've been there and they make fewer mistakes. Uh, but then the warehouse might go through a period where it's less busy. So is it a good idea to let those people go? And then when it picks up to get other people, but then you have to retrain them for that period. So indeed, so you can create within these different people or operators a certain skill level. And the longer they work at a job, the higher their skill level becomes. Maybe if they work with someone who's really a very good and experienced person or trainer, then their skill level increase. If they don't work for a certain time, it decrease. So one can do all of those things, which correspond to how things work in real life.
Yeah, so if you could just indulge me, I did not mention the fact that these different pieces of equipment might have different performance levels, even the equipments themselves.
Yes.
Some you work at a slower rate and others maybe higher. Same with the operators, depending on the skill level. So
Yes.
I was just also looking at that variable.
Yeah. So it could be that and you might have data and that data can be incorporated in the model. So you can look at different equipments and because the equipment is older, it is maybe least effective. But if you have someone who's highly skilled, they know how to get most out of it. Whereas if you have someone who's less skilled, they would not be able to do that. Or different bits of equipment that need certain skill levels to be able to operate it to the maximum amount. So all of those kinds of things can be incorporated in AnyLogic specifically because it supports agent-based modeling. But you obviously need some kind of data, and what we sometimes do too for our projects, because we provide the software, training how to use the software, but we also provide consulting services. And then also the data analysis of that statistics that you might have on operator behavior. Good. Someone
Very
from
good.
Richards Bay.
Yeah, I think we have one more question. Time for one more question.
Good afternoon to you and the colleague online. My question is pretty much simple. Is it possible that we join models from different areas within the business so that if someone has already built a rail part of it, and someone is doing on offloading the wagons within the port, and someone does another thing. And once that is done, if it's possible, can you the system allow multiple scenario creation from all the three people that were worked on it, so that they can see how they influence each other's models in a way so that they can try and develop a solution that works for the value chain as a whole. Thank you.
Yes, that's a very good question. And that's indeed what we see, that very often people do silo optimization. They just optimize it for their particular business unit, and they don't see what the effect of them not quite performing or overperforming might be. So what one can do with AnyLogic is to have different people develop different models. And remember, that was the sort of graphic that I showed previously, where you had the factory and distribution center and so on, different parts linked with different lines. So you might have different models for each of them. Your port to pit, or pit to port, the mining, initial mining, your rail shunting and operation, and then what's happened at the port, the vessels coming in, including demurrage and so on. And then people can run those models linked to each other and then see what the total effect would be, instead of just looking at their one particular model, just the mining aspect, for instance. And I actually have such a model which I'll share. And the nice thing is these or examples that I have, I can send you links to them, and you can then run them in the cloud without having to install anything or download anything on your PC. Good.
Thank you, Clemens. Yeah, that'll be wonderful if you could share the links with us. So we've run out of time, but thank you all for joining. I'm sharing a link in the chat to our upcoming summit event. We have a masterclass with our colleague, this is Clemens and I's colleague, Dr. Giovanni Manzambi, and this will be a full day workshop on AnyLogic, the opportunity to get into the system, understand the nuts and bolts, how this works from a simulation modeling standpoint for your environment. So I recommend you check out that. We'd love to see you there. And then otherwise, we'll be sending out the recording from today's event along with those links you mentioned. So Clemens, thank you as always for joining, and thank you everybody for tuning in. We will talk to you soon.
Thanks, everyone.
Thank you.
Thank you.